Welcome, students. Today we're going to learn a new concept about trigonometric ratios. Trigonometric ratios basically always deal with the right triangle. So it's very important that you will see a triangle that has a right angle in it. Now the trigonometric ratios, we have three basic ones. One's called the sine ratio, one's the cosine ratio, and one's the tangent ratio. And yes, this is pronounced sine. They abbreviate it sin, so that's not sin, but it's sine of A. This is cosine of A, and this is tangent of A. Now, when I say A, I'm referring to this angle A down here, because we could actually refer to this angle up here, whatever letter we want to give this. If it was a B, we could do the sine of B rather than the sine of A. But that would adjust how we label the sides. So let's talk about what I mean by labeling the sides. In a right triangle, we have two sides that form a right angle. The third side that doesn't form the right angle is always called the hypotenuse, and it's always the longest. So the longest side, the side that doesn't make the right angle, is always called the hypotenuse. Now, depending on what angle we're looking at, if we're looking at angle A, which we're going to look at this time, the other two sides are given the names of opposite and adjacent. Now, the way you'll know which is which, the adjacent side is always one of the sides of the angle that forms the angle with the hypotenuse. So the hypotenuse and this other side is considered the adjacent, forms angle A. The side that doesn't form angle A, or isn't actually one of the two sides of angle A, is called the opposite. I like to just think of it as opposite side of the triangle. If you run across this triangle here, we're going to end up at the opposite side from angle A. So again, the opposite side is across from the angle. The adjacent side forms the angle we're looking at with the hypotenuse. Now this will make a lot more sense, I think, when we get to numbers. So let's deal with one with numbers. Oh, I'm sorry. Let's talk about exactly what the sine, cosine, and tangent ratios are first. The sine ratio, so if I ask for the sine of A, it's actually the ratio of the opposite side divided by the hypotenuse. So the length of this side divided by the length of that side, which is just a fraction. You could write it as a decimal, which you will be doing later. The cosine is the ratio of the length of the adjacent side with respect to the hypotenuse, or over the hypotenuse. So the cosine is the adjacent divided by the hypotenuse. The tangent is the ratio of the opposite side divided by the adjacent, or the length of the opposite divided by the length of the adjacent. Like I said, this will make more sense with numbers, so let's look at one with numbers. We have this right triangle here. There's a right angle. We have this angle A. The first thing I would always recommend you do is you label your sides. If this vertical side and horizontal side form the right angle, I'm going to make sure I write this third side is the hypotenuse. That's supposed to be a hypotenuse, abbreviated HYP. If this is angle A, the hypotenuse makes angle A with this length down here, or this side 4, so this would be the adjacent side. And the side across from it, again, I like to point over to it, the side across from it is considered the opposite, or the side opposite. Now that I have my sides labeled, I can actually find my ratios. Because remember, the sine is the opposite side divided by the hypotenuse. So it'd be this length of 3 divided by 5. So it's just 3 over 5. That's simple. The cosine is the length of the adjacent side divided by the hypotenuse. So the cosine of this angle would be 4 over 5. 4 over 5. And that's a weird looking 4. Wow. And then the tangent of angle A is the opposite over the adjacent. The opposite side is 3, the adjacent side is 4, so it'd be 3 over 4. I am not very good at writing with a mouse, so I'm going to do it a little differently here in a minute. But you get the idea that the ratio is these are the trig functions, or the ratios of these sides. Let's do one more, because I want to emphasize that the triangle could be oriented differently. For instance, the right angle is at the top. So that makes down here the hypotenuse, and it makes the other two sides either the opposite or the adjacent. But now we got to look at which angle we're referring to. We're referring to the sine of D, cosine of D, tangent of D. That's this angle over here. Well, if that's this angle here, this hypotenuse forms that angle with this side length of 8. That makes this the adjacent, not the opposite, but the adjacent. And if there's my angle, I look across, makes this side length of 6 the opposite. Now I can find my sine. If you don't remember, sine is opposite over hypotenuse, and I would recommend writing those ratios down so you have them when you do your notes or when you do your lesson. Opposite from this angle is 6. Hypotenuse is, we don't know the hypotenuse. This is another situation where it's nice it's a right triangle. We can use Pythagorean's theorem. We can use that a squared plus b squared equals c squared. And so what I'm going to do is I'm going to square the 6, that's 36. Add it to 8 squared, that's 64. That gives me 100. And that 100 equals c squared, so I got to square root that value. When I square root it, I get this hypotenuse is 10. So you gotta, if you need to go back and review the Pythagorean theorem, go back and review Pythagorean's theorem because you'll need it. Now I know that the sine, again, is the opposite over the hypotenuse. It's going to be 6 over 10. And yes, you need to reduce your fractions if possible. So 6 over 10 actually reduces to 3/5. The cosine of this angle is the adjacent over the hypotenuse. Adjacent is 8, hypotenuse is 10, so that's 8 over 10, but that reduces to 4/5. And then the tangent of D, tangent is opposite over adjacent, opposite over adjacent. Now be careful, adjacent's not 10, adjacent's 8. So it's 6 over 8 or 3/4 when we reduce. So let's look at some of the ones you're going to do in your homework, in your assignment today. And I'm going to show you how to do this a little easier because I'm going to use paper and pencil. What I'm going to do is I'm going to use this right here. Allows me to actually write by hand, which I find so much easier. So here's like the first thing we're going to be doing IXL in the algebra, section HH, number 1. Here's a right triangle, and it says find the tangent of J. So the first thing I do is I notice J's down here. What I would recommend doing is on a separate sheet of paper, draw that little triangle, put your right angle, put this little, that's the angle I'm looking at, angle J. Now I'm going to label my sides. This is my hypotenuse because it's the side that doesn't form the right angle. I'm looking at this angle here, which is the hypotenuse in this side, so that makes this side the adjacent, and it makes this side the opposite. Now that I have my sides labeled, I'm going to put in the numbers that they give me, 39, 89, and 80. So this side is 39, this side is 89, and this side is 80. And now I can actually find my ratio, tangent. If you don't remember, tangent of angle J is going to be the opposite over the adjacent. So I come here and I look at the opposite, which is 80, and I divide it by the adjacent, which is 39. Now, what's nice about this lesson is it's going to ask you to give your answer is a decimal rounded to the nearest hundredth. So you don't have to worry about reducing the fraction. You just take your calculator and do 80 divided by 39. Hopefully you can see that right here. It's 2.051. Now, since this is a 1 and we're rounding to the nearest hundredth, I'm going to leave the 5 alone and type in 2.05. So I come over here, 2.05, and hit enter, and I did a great job. Now, again, you're going to get to some that are missing side lengths. So for instance, you're going to eventually get to ones that look like this. So again, what I would recommend doing is draw that triangle on a sheet of paper, mark the right angle, mark the angle you're looking for. We're looking at the sine of t. That's this angle down here is t. So it's set up just like the one above it, where this is going to be the hypotenuse, this is going to be the opposite, and this is going to be the adjacent because it's the side that forms the angle t with the hypotenuse. Now I'm going to fill in the two numbers I have, 8 and 15. 8 and 15. And since I'm looking for the sine, I'm going to need the hypotenuse. So I need to perform Pythagorean's theorem. I'm going to go 8 squared plus 15 squared equals c squared. And then I just grab my calculator and go 8 squared plus 15 squared is 289 is equal to c squared. Now I'm going to square root that 289, and I get c is 17. So now I come back over here, put in a 17. Now I can find my sine of t, and that's what we asked for over here, sine of t. Sine is opposite over hypotenuse. What's the opposite? It's 15. What's the hypotenuse? It's 17. And then I grab my calculator and I do 15 divided by 17, and I get 0.882. Since this is a 2 here, I'm going to leave the 8 alone and type in 0.88. My answer. Now, you're going to get to some that have square roots in them, like this one. Do not let it confuse you. It's no harder than the other ones, other than you just need to be careful when you square. So here we go. First thing I'm going to do is I'm going to draw that triangle. I'm going to put the right angle right here. I'm going to say I'm looking for the sine of f. Now, f is up here at the top. So I'm going to put it up here at the top, f. Which means that if this is my right angle, this would be my hypotenuse. This right side that forms angle F with the hypotenuse is my adjacent, and this bottom side here is going to be the opposite. Now I'm going to put in the numbers that I know, the square root of 62, the square root of 53, and let's say I didn't know this side. It gives it to us that it's 3, but I just want to show you if we didn't know what this side is, how you would find it. You would say, all right, let's say this side's some unknown length x. I would go x squared, that's one of the legs, plus the square root of 53 squared equals the hypotenuse squared. Because remember, it's the hypotenuse that's always by itself in Pythagorean's theorem. A squared plus b squared equals c squared. Now I would go x squared. Now a square root that's then been squared cancels, leaving just the 53. The square root of 62 that's been squared, they just cancel, leaves 62. So I'm not actually squaring 53 and 62. I'm actually undoing the square root with the square. Now I minus the 53 over. I'm going to get 9, and then I square root and find x is 3, which is what it did tell us that side length was. But I wanted to do that example in case it was missing a side and it had square roots, that you would be able to see an example of how I squared to get rid of the square roots. Now I'm going to come down here and find the sine. The sine of f is equal to, sine is opposite over hypotenuse, not adjacent, opposite over hypotenuse. So it's going to be 3 over the square root of 62. Now again, this is why I like these, are make it easy. I'm going to use my calculator. I'm going to go 3 divided by the square root of 62, and that gives me 0.381. But since I'm rounding to the nearest hundredth, I'm just going to go 0.38. I'm going to come over here, type in 0.38, hit enter, and I get my answer. So again, as you work through these, you're going to get some that are missing, like this one, it's missing this third side. And so, in fact, let's do this one. I'm going to take an extra minute on this lesson to do this one. So you see an example. I'm first going to draw that right triangle on my paper. I'm going to label the right angle, and I'm going to label the angle I'm looking at. I'm looking at the tangent of H. H, it happens to be this one over here. So I'm going to put this as H. Now I'm going to label my sides. If this is my right angle that's formed by these two sides, then this is my hypotenuse. If the hypotenuse forms angle H with this side, this is my adjacent. And then that leaves only one left side for the opposite, which is across from H. Now I'm going to put in the values I know. I know this one's the 3 square root of 10. I know this one here is 8. Now I'm going to have to use Pythagorean's theorem to find this missing side. Now, remember, the hypotenuse is always the one by itself. So I'm going to label this x, and I'm going to go x squared, that's like a, plus b squared, 8 squared, equals 3 square roots of 10 squared. I want to make sure I do this one so you can see how to square this here. But first, x squared plus 8 squared is 64. The way I do this is 3 squared is 9 times the square root of 10 squared. The square root and the square cancel, so it leaves a 10. So I did actually square the number on the outside of the square root, but I didn't square the number on the inside because it cancels, the square root cancels that squared. So I get 9 times 10, or x squared plus 64 equals 90. Now I'm going to minus 64 from both sides, and I get x squared equals, I believe that's going to be 26, or x equals the square root of 26. Now, it's all right to leave it as a square root. Just come over here and put the square root of 26 for this opposite side. Now I'm going to go back to look to see what I needed, the tangent of H. So I'm going to go the tangent of H equals, now tangent is opposite over adjacent. So what's the opposite side from H? It's the square root of 26 divided by the adjacent side, which is 8. So I grab my calculator and I go the square root of 26. Now I'm going to make sure I get out from underneath the square root, divided by 8, and I get 0.637. Since 7's large, 5 or larger, I'm going to round that 3 up to a 4 and type in 0.64. Come over here, type in 0.64 and submit, and we did it correctly. So if you have any questions, please contact me via email, or you can maybe log on at 1 o'clock during my online open office hours via Zoom. And we will talk to you later.